All right, I am going to do the hypothesis test for the ratio of population variances. This time we are going to do one that's a two-tailed test. It says a new study on the widely used antidepressant AD+ has been published. A study has information on the side effects of the drug. For each of the 19 randomly chosen users of AD+ who participated in the study, a score of 0 to 100 was assigned according to the severity and variety of side effects from the drug. A score of 0 meant no side effects. A similar assessment was made for 28 independently and randomly chosen users of the competitor antidepressant XAD24. The data are summarized in the following table. So we've got our data there, and it says the first row gives the sample means, the second row gives the sample variances. Assume that the populations of side effects scores for each of the drugs are approximately normally distributed. Can we conclude at the 0.05 significance level that the variance of scores for all AD+ users is different from the variance of scores for all XAD24 users? So we are going to do a two-tailed test here. So again, I am going to put in my information here. My variance is my standard deviation squared. So I'm going to do for the first, and then I'm going to highlight that and do my fraction. I could hit my fraction button first. Standard deviation squared for the second. And we are going to say that it is equal to, since we're doing a two-tailed test, 1. Again, since I'm using Chrome, I'm just going to copy and paste and change my equal to not equal. Are they different? Which is what my question is asking me. Can we conclude that it's different? So I've got my variances comparing, are they equal to 1 or not equal to 1? Of course, we're doing an F-tailed test. The degree of freedom in the numerator, I have to read here, we had 19 for the first one, so 19 minus 1 would be 18. My degree of freedom for the denominator, it was 28 for the second sample, 28 minus 1 would be 27. So I've got those in there. Find the value of my test statistic. So I'm going to grab my calculator here. I am going to take the variance of the first, 146.41, divide, 146.41 divided by the variance of the second, 331.24. So for 146.41 divided by 331.24 is 0.442 for the value of my test statistic. Now, here's the part that's a little bit different than what we normally do, finding our critical values. Since it's a two-tailed test, the first thing I have to do is take my level of significance, 0.05, and divide it by 2. And so I'm going to use 0.025, and I am going to do the left-tailed and the right-tailed. So for the left-tailed, I have to do the 1 minus. So I'm going to have F sub, I'm going to sneak the 1 minus in there, F sub 1 minus the 0.025. The degree of freedom in my numerator was 18, and in my denominator it was 27. And so since the left side, I have to do 1 minus that value. And so I'm going to have 0.405 when I round that to 3 decimal places. Then for the right-tailed test, I'm going to clear that again. Again, I have the 0.05 level of significance, but I had to divide it by 2 since I was doing the two-tailed test. And so for the right-tailed test, I just do that F sub and use my 0.025 in there. Degree of freedom in numerator is 18. The degree of freedom in the denominator is 27. And so when I calculate that, my other critical value is 2.291. 2.291. So my null hypothesis would be if my test value falls in between those two values, my alternative hypothesis is, would it be less than the 0.45 or greater than the 2.291? In this case, our test statistic is 0.442. Since 0.442 is in between, in the middle of our two critical values, we have to assume that the null is true, that there is not a difference, that they are equal. So it says, can we conclude that the variances of scores for all 80 plus users is different? No, we cannot conclude they're different because we are saying that they're equal, since our test statistic falls between our two critical values. It's not to the left of the smaller one or to the right of the greater one. I'm going to go ahead and hit check here. And if I slide up here to the top, you can see we have that correct. All right, good luck.